Hi everyone, I'm Yogesh Mohan. This video presents my Google Generative AI Capstone project, which I call Beyond Alt Text, Building a Personalized AI Narrator for Accessibility. In this project, I explored using Google Cloud's Vertex AI platform, particularly the Gemini models, to tackle a key challenge in digital accessibility for visually impaired users. In this video, we will look at the accessibility challenge with standard image descriptions, and then I will walk you through the personalized narrator solution I built using Vertex AI. And then next, I will show the demo of my project right from the Kaggle notebook, and then we will see the impact and the future directions. All right, let's dive in. So for the problem statement, as we all know, standard alt text is vital for accessibility, but often it's generic. A painting of a woman doesn't help an art student analyze techniques, and butterfly on flower doesn't satisfy a botanist curious about the species. So this creates a gap in understanding and engagement for visually impaired users with specific passions. To tackle this challenge, the solution I explored is the personalized AI narrator. I built this prototype using Vertex AI Gemini with the goal of moving beyond those generic descriptions. It works by automatically generating narrations that are specifically tailored to the individual user's interests, aiming for a much richer and more relevant experience with images. Next, I will explain the personalized AI narrator workflow. It starts when the system gets an image. First, a Gemini vision model analyzes it to create a really detailed based description. Because descriptions can be long, I then break that text down into individual sentence chunks using NLTK. Next comes the semantic part. Using the Vertex AI Embeddings API, I generate numerical vectors or embeddings for both the user's interest and each sentence chunk. So the core idea is then to compare these embeddings using cosine similarity. So this finds which sentence chunks are most semantically related to the user's interest. So the system selects the top 5 most relevant chunks. Finally, these selected chunks along with the user's profile are fed into another Gemini text model. Using prompt engineering for control generation, these models synthesize those relevant parts into a new, concise, personalized narration, making sure it stays grounded in the original image context. At the heart of this prototype is Google Cloud's Vertex AI platform. I leveraged the Gemini model for powerful image understanding using Gemini 1.5 Pro 002. And then for control generation and Gen AI evaluation, I used Gemini 2.0 Flash and then Vertex AI Embeddings API with text embedding 004, provided the vectors for semantic matching. So for this project, I mainly worked on 4 Gen AI capabilities: image understanding, embeddings, control generation, Gen AI evaluation. And then for interface, I worked on Vertex AI SDK for Python. And then for development environment, I used Kaggle notebook. Next, I'm going to show the demo of my project development. So let's see it in action. So now I will show you the key outputs from the section 4.2 of the notebook where the full workflow runs. So here the notebook running with the test image. So basically here we can see this vibrant plain tiger butterfly on a Gylardia flower. So first the system generated this detail based description using image understanding, noting the species, colors, and context. So it's actually a good start, but the same for everyone. And then for this project, I worked on 3 persona. So first we're going to look at the Evelyn Reed. So first persona. So now for Evelyn, she's actually a botanist. So based on her interest, the narrator generated this personalized description. So here it said that Evelyn observes the striking blanket flower showcasing fiery red and yellow petals, a color scheme mirrored in the flower it supports, though with a more intense red and yellow center. Note the slightly textured surface of the petals and the light green stems, a detail that might offer insights into its specific ecological niche or ideal gardening conditions. So we can see here that actually we notice the focus on the specific botanical terms found in those relevant source text chunks. So here the automated Gen AI evaluation confirmed this was effective, giving it a strong score of 4 out of 5 for grounded relevance. So if we go to the Okay, if we go to the third persona, so but for the same image, Anya, the art student, received this description based on her most relevant chunks. So here we can see the personal description saying that Anya, imagine a close-up study, much like a Renaissance master's preparatory sketch, capturing a butterfly poised on a flower. The composition uses a blurred background to isolate the subjects, creating a sense of depth reminiscent of fumato, while the rich palette of reds, oranges, and yellows, punctuated by green, evokes a vibrant yet fleeting movement, hinting at the delicate textures that might be revealed through careful conservation. So, however, the Gen AI evaluation scored this lower, so 2 out of 5. So why? So basically because those specific art history connections were not strongly supported by the actual text chunks selected from the basic description. So this objectively shows the system's current limitation. So it's actually a grounded personalization depends heavily on the details present in the initial analysis. So the core of this control generation is the prompt structured like this. So telling the AI exactly how to synthesize the selected context based on the user profile. So this comparison shows how the semantic approach adapts, but also how the evaluation helps us understand the boundaries based on the source information. So yeah, so that's the end of the demo. So, what's the bigger picture here? This prototype really shows the potential for using generative AI to create much richer, more inclusive, and equitable digital experiences through personalization. With over 1 billion preventable or unaddressed vision impairment cases globally reported by the World Health Organization, tools that enhance digital access like this matter significantly. By moving beyond generic descriptions, personalized narration can empower visually impaired users to connect more deeply with visual content based on what truly interests them. As my results demonstrated during the demo, a key limitation of the current grounded approach is its dependency on the details captured in the initial image analysis. So, to overcome this and provide truly rich context, even when visual details might be sparse in the original description, important future work should focus on integrating external knowledge sources, perhaps using techniques like retrieval augmented generation. Developing seamless integration with common screen readers and web browsers is another vital next step to make this functionality practical and readily available for everyday use. To wrap things up, the personalized AI narrator prototype I built showcases what I believe is a novel application of Vertex AI Gemini focused specifically on enhancing digital accessibility. So, by tailoring image descriptions to individual interests, it offers a glimpse into a future where visual content isn't just described, but truly brought to life for everyone. respecting their unique perspectives. While challenges remain, especially around context and grounding, the potential for using generative AI to foster greater digital inclusion is truly immense. Finally, I would like to extend a sincere thank you to Kaggle teams for this fantastic generative AI capstone learning opportunity. It's been incredibly insightful. So you can explore the full implementation I developed and try it yourself in the Kaggle notebook. So I have shared the link in the description. So yeah, thank you so much for watching.